In today's video, we are going to learn about circle theorems. So, circle theorems is an important topic in IGCSE math. It comes out in the question paper often, and then it normally worth like 6 to 4 marks, and then which is super important to understand. So let's dive straight in. So, circle theorem. First of all, we have this alternate segment theorem. So basically, we have this angle here, which is equals to this angle. It also works to the other side. This angle is equal to this angle. So, in the exam, if it has those lines and asks you to put your working out, you could just write the title, alternate segment theorem, or you could just write those texts on the right, and to prove that you know this. And the second one, angle at the center theorem. So this is the angle at the center is twice the angle at the circumference. So if we draw a line over here, this is the chord. So you can see that these two triangles, these two angles, both is on the single chalk. So, but one is at the very edge of the circle, one is at the center. So we could see over here, there's an angle, right? This angle is equals to half the angle, to double the angle over here. So we could write angle DAB is equals to 1 over 2 angle BCD. Okay, so that is the second one. Now let's look at the third one. Angle at the same segments theorem. Okay, for this one, we have a common core also over here, DB. That's a common core, chalk. And then both of the other angles are at the very edge of the circle. So in this case, those two angles are the same. So we could just write angles at the same segments are equal. Okay, now the next one. Angle at a semicircle. So as you see, there's a chalk over here, and then there is a point B. But this AB line crosses the mid. And then this BC is so this is the angle over here. So this angle is 100% 90 degrees if this thing happens. So in example, we could just write the angle in a semicircle is 90 degrees. So if you don't look at this side of the triangle, this side of the circle, that is the other side. This side is a semicircle. So you have a point C over here, and then that is connected. So this angle is 90 degrees. Okay, so now let's look at the next one. Chalk of a circle. So we first draw a line from the mid to the edge of the circle. Now we draw a chalk right through it. If this is 90 degrees, then these two are parallel. And we can also do the opposite. If these two are parallel, are equal, this is 90 degrees angle. So that is the perpendicular from the center of a circle to a chord bisects the chalk, splits the chalk into two equal parts. That is the thing that we just explained. Okay, for our next one, a cyclic quadrilateral. For this one, the opposite angle in a cyclic quadrilateral is equal to 180 degrees. This means that, as you see inside the circle, there's like a 4 point shaped quadrilateral, and it's inside the circle, so it's called a cyclic quadrilateral. And then the opposite angle, which is this angle and also this angle. So it is this angle and then this angle. So these two angles add up to 180 degrees. So basically, angle DAB is equal to angle, not equal, sorry, plus angle DCB is equals to 180 degrees. Okay, we know this, and we can just write in exam the opposite angle in a cyclic quadrilateral total is 180 degrees. Okay. For our next, the last one, tangent of a circle. So this is outside of the circle. So outside of the circle, you draw a line that is connected to the circle. This is called a tangent. So a tangent basically means from a midpoint B to the edge of the circle, and then draw a line that is touches only one point touches the circle. And the angle degrees over here is 90 degrees. So this line is so called a tangent. So a tangent circle. So for the first one, the angle between a tangent and the radius is 90 degrees. So the radius, the tangent, the 90 degrees. Okay, for diagram B, the tangents which meet at the same point are equal in lengths. So we have a point over here, A, and then we draw two tangents over here. And then we have these two, which is this. So from A to B, so for this one, it is AB is equals to AD. These two lines are equal from this point. And this is all of the circles theorem that you will be asked in exams. So if you want to see, if you want to print this thing out, this paper out, I'll send it in the description, the chat below. So you can use it to revise for your exams. Thank you.